Good day, everyone. Our discussion for today will be about the part 2 of the topic, product and service design. One of the strongest motivators for new and improved products or services is competitors' products and services. By studying competitors' products or services and how the competitors operates, such as in pricing policies, return policies, warranties, location strategies, and many others, an organization can glean many ideas. Beyond that, some companies purchase a competitor's product and then carefully dismantle and inspect it, searching for ways to improve their own product. And this is called reverse engineering. When we say again reverse engineering, this is the process of dismantling and inspecting a competitor's product to discover product improvements. Research is another source of ideas for new or improved products or services, and also organized efforts to increase scientific knowledge or product innovation, and may involve the basic research, in which advances knowledge about a subject without near-term expectations of the commercial applications, applied research that achieves commercial applications, and development that converts results of applied research into commercial applications. Now let's proceed to manufacturability. This is a key concern for manufactured goods. The ease of fabrication or assembly is important for the cost, the productivity, the quality. With services, ease of providing the service, cost, productivity, and quality are of great concern. A good design must take into account not only how a product will be fabricated, but also how it will be assembled. Design for assembly focuses on reducing the number of parts in assembly or in non-assembly, as well as on the assembly methods and sequences that will be employed. To achieve a smoother transition from product design to production and to decrease product development time, many companies are using simultaneous development or concurrent engineering. In its narrowest sense, concurrent engineering means bringing design and manufacturing engineering people together early in the design phase to simultaneously develop the product and the process for creating the product. Again, concurrent engineering is the bringing together of engineering device or design and manufacturing personnel early in the design phase. Computer-aided design is all about the concept wherein computers are increasingly using or used for product design. And this uses graphics for product design. The designer can modify an existing design or create a new one on a monitor by means of light pen, keyboard, joystick, or a similar device. Once the design is entered into the computer, the designer can maneuver it on screen. It can also be rotated to provide the designer with different perspectives. It can be split apart to give the designer a view of the inside and a portion that it can be enlarged for a closer examination. The designer can obtain printed version of the completed design and file it electronically, making it accessible to people in the firm who need this information, such as the marketing and the operations. Computer-aided design or CAD, again, is a product design using computer graphics and increases productivity of designers 3 to 10 times. This also creates a database for manufacturing information on product specifications and provides possibility of engineering and cost analysis on proposed designs. Now let's go to recycling. Recycling is sometimes an important consideration for designers, and companies recycle for a variety of reasons. First is cost savings, environmental concern, and environmental regulations. For service design, there are many similarities between product and service design. However, There are some important differences as well. Owing to the nature of services, one major difference is that unlike manufacturing, where production and delivery are usually separated in time, services are usually created and delivered simultaneously. Service refers to an act, something that is done for a customer, client, patient, etc. It also provides a service delivery system, which includes the facilities, processes, and skills needed to provide the service. Many services are not pure services, but part of a product bundle, in which this is a combination of goods and services provided to a customer. Service design also includes the physical resources needed, the goods that are purchased or consumed by the consumer or the customers, the explicit services, and the implicit services. Service design begins with the choice of a service strategy, which determines the nature and focus of the service and the target market. This requires assessment by the top management of the potential market and profitability of a particular service and an assessment of the organization's ability to provide the service. Once decisions on the focus of the service and the target market have been made, the customer requirements and expectations of the target market must be determined. Service design is all about service. Service means something that is done to or for a customer. Again, this is also about service delivery system, the facilities, processes, and skills needed to provide the service, product bundle, the combination of goods and services provided to a customer, and service package, the physical resources needed to perform the service. Service operations manager must contend with issues that may be insignificant or non-existent for managers in a production setting. And this include the following. Products are generally tangible. Services are generally intangible. Consequently, service design often focus more on intangible factors than does product design. In many instances, services are created and delivered at the same time. In such instances, there is a less latitude in finding and correcting errors before the customer has a chance to discover them. Consequently, training, process design, and customer relations are particularly very important. Services cannot be inventoried. This poses restrictions on the flexibility and makes capacity issues very important. Services are highly visible to consumers and must be designed with that in mind. This adds an extra dimensions to process design, one that usually is not present in product design. Some services have low barriers to entry and exit. This places additional pressure on service design to be innovative and cost-effective. Location is often important to service design, with convenience as a major factor. Hence, design of services and choice of location are often closely linked. The phases in service design process are as follows. First, conceptualize. Next, identify service package components. Next, determine the performance specifications. Fourth is translate performance specifications into design specifications. And then translate design specifications into delivery specifications. A useful tool for conceptualizing a service delivery system is the service blueprint, which is a method for describing and analyzing a service process. A service blueprint is much like an architectural drawing, but instead of showing building dimensions and other construction features, a service blueprint shows the basic customer and service actions involved in service operations. Service blueprinting is a method used in service design to describe and analyze a proposed service. This is a useful tool for conceptualizing a service delivery system. The major steps in service blueprinting are as follows. First, establish boundaries. Second, identify steps involved. Next, prepare a flow chart. Fourth, identify potential failures point. Establish a time frame. Analyze profitability. Here's an example of a service blueprinting for a hotel, or service blueprint of Shangri-La Hotel. For this figure, this illustrates a simple service blueprint for a restaurant. At the top of the figure are the customer actions, and just below are the related actions of the direct contact service people. Next are what are sometimes referred as backstage contacts. In this example, the kitchen staff, and below, those are the support or backroom operations. So in this example, support operations include the reservation system, the ordering of food and supplies, cashier and outsourcing laundry service, also a simplified illustration. Typically, time estimates for actions and operations would be included. This is an example of service blueprinting for restaurant or quick service restaurant. The characteristics of well-designed service system. First is to be consistent with the organization mission. Next, it should be user-friendly. Next, it should be robust. 4, it should be easy to sustain. Must be cost-effective. Should emphasize value to customers. And should have effective linkages between back operations. And should have single unifying theme. Of course, ensure reliability and high quality. Variability is a major concern in most aspects of business operations, and it is particularly so in the design of service systems. Requirements tend to be variable both in terms of differences in what customers want or need, and in terms of the timing of customer request. Because services generally cannot be stored, there is additional challenge of balancing supply and demand. This is less a problem for systems in which timing of services can be scheduled, but not so in others. Another challenge is that services can be difficult to describe precisely and dynamic in nature, especially when there is a direct encounter with customer. Of course, especially when the customers are in high volume. These are the guidelines for successful service design. First is to define the service package in detail. A service blueprint may be helpful for this. Second is focus on the operation from the customer's perspectives. Consider how customer expectations and perceptions are managed during and after the service. Next is consider the image that the service package will present both to customers and to prospective customers. Fourth, recognize the designer's familiarity with the system and may give them a quite different perspective than that of the customer and take steps to overcome this. Fifth is to make sure that the managers are involved and will support the design once it is implemented. Sixth, define quality for both tangibles and intangibles. Intangible standards are more difficult to define, but they must be addressed. 7, make sure that recruitment, training, and reward policies are consistent with service expectations. Establish procedures to handle both predictable and unpredictable events. And 9, establish systems to monitor, maintain, and improve the service. Obtaining input from customers is essential to assure that they will want what is offered for sale. Although obtaining input can be informal through discussion with customers, and there is a formal way to document customer wants. Again, for the quality function deployment, we have the voice of the customer as its primary concern, and then we also have the house of quality. And when we say QFD approach, this integrates the voice of the customer into the product and service development. For the house of quality, we have here the correlation matrix, the design requirements, the customer requirements, the relationship matrix, the competitive assessment, and the specifications or target values. So we have here an example for the house of quality. So again, this area is for the correlation matrix, the design requirements. We also have here the customer requirements, the relationship matrix, the competitive assessments, and the specific target values. Another example of house of quality for pizza restaurant. So here they included the interrelationship between the house. So in this part, this is the correlation matrix. And then this is the technical descriptors for the design requirements. And then we have here the relationship matrix between what and house. And then for the competitive assessment, they have here prioritized customized requirements. And then for the customer requirements, they have the customer requirements as their answer to what's. And then for the specific target values, they have their prioritized solutions. Operation strategy is the way of increasing emphasis on component commonality. This is also about the packaging of products and services, use of multiple platforms, consider tactics for mass customization, look for continual improvement, shorter time market or shorten time to market. And when we say shorten time to market, this is the use of standardized components, the use of technology, and the use of concurrent engineering. And that's it for the topic, part 2 of the product and service design. Thank you very much and stay safe, everyone.